Hello everyone, it's January the 28th. Alright, look at this. What the hell is this? Alright, we have hot for 3 days. We have nothing but... We had nothing but maggot what? Maggot-filled bread for 3 stinking days. Yeah! When can we have some fresh? When can we have some meat? They look fresh. They are not for eating. Why? How about them legs? Yeah, they are to be brought back alive and unspoiled. What are you doing, man? What are you doing? Yeah, I'm remembering that scene. Looks like meat's back on the menus, boys. Yeah, that was wonderful. Wonderful piece. Alright, LFU cache. A data structure least frequently used. Oh, I remember. I don't remember how to implement it. I remember this problem. Initialize the object with the capacity of the data structure. Get gets the value of the key if the key exists, otherwise return -1. Put key value, update the value. If present, insert the key. If not already present, when the cache reaches its capacity, it should invalidate and remove the least frequently used key before inserting a new item. For this problem, when there is a tie, the least recently used key will be invalidated. To determine the least frequently used key, a use counter is maintained for each key in the cache. The key with the smallest use counter is the least frequently used key. When a key is first inserted into the cache, the use counter is set to 1. The use counter for a key in the cache is incremented. Either a get or put operation is called on it. The functions get and put must each run an O1 average time. Okay, so we'll do capacity is 2, right? And I'll put key, so 1 to 1, 2 to 2, and I'll get 1. So 1's actually have 2 times used. And put 3. Now get 3. Get 3. Wait, hold on. Let's put 3. 2 is the least. Invalidate 2. So cache. That is count 3 is 1. Count 1 is 2. Yes. Get 2 not found. Get 3. And 3 become 2. And put both have the same count. 1 is the least recently used. Jesus, invalidate 1. And I'll get 1 not found. Get 3. 3 is this. Get 4. 4 is that. And then 4 is 2 times. Yep. Oh boy. But I mean, we can count, right? Everything will count, and then it want to say get must each run O1 average time. How? When are you gonna do the counting? When are you gonna do the operation? I mean, we did LRU cache. I think that's a W linked list. That's when we do the LRU cache. This one is least recently used cache. Least frequent. Okay. O1. O1. You gotta be kidding me. O1. Where you do the computation, you have to do in get and put. It just has to be very fast, right? Okay, so when you get something changed, it has to be log in, right? It has to be. It has to be. There's no way around if you want to use. So are you saying? I think this is what I think. I think if we do just the priority queue, I think it will work. Okay, so basically we need to prepare a priority queue. Oh yeah, on average, if we keep doing get, nothing can happen. So we do a priority queue, and then we will hold a dictionary as well. And then, holy crap. And then what? The priority queue, we're gonna do its frequency. Right? It's gonna be the frequency and used. Most recently used. Most recently used. Every time we use, we will get bigger. Most recently used. It says the least recently used. Least recently used. Yes, it's a negative value. Oh, a clock. Yeah, we can do a clock, so it will tick. Yeah, that's fine. Will tick. Then the smallest will go to the top. Okay. So yeah, we have a queue, and then we'll just order the queue. We define a smaller than. Then every time we order, it will. Yeah, every time we order, it will put the one we want at the front. We have to do it that way, right? Like a list, and then we just put the, we put the. We put, and with something when we pop it, when we remove. So it's a dictionary, right? We need a dictionary, and we need a priority queue. And the priority queue, the first is going to be number of times used. Second will be the last time it is used. Not sure. Proof of concept. Okay. Import heap queue. Okay. So we can say A is equal to. I need a dictionary. Let's say value 1, 2, 2, value 1, 1. Okay. And then heap equals to A1, A2. Okay. And then we say heap q dot heap phi heap. Now we check heap 1, 1, 1, 2. Yeah, I think it does work. I'm gonna give it a shot. Capacity. Capacity. Self dot map equals dictionary. Self dot heap equals this. And we need to import heap queue. So when we get, if else we'll return -1, right? If it does not exist, okay? We say if key not in self.map, return -1. Otherwise return self.map key. Yeah, that's always a 1 put. Put. So we need to first check what? Because it's key value, right? So the size of heap or the size of map has to be equal to, right? When they say, I want to put something, we say if self.heap is, len self.heap is equal to self.cap. That's why we need to pop one. So we need to pop the top. Okay, so we need to say, when we pop, what's stored inside? Well, we're going to store three things. The frequency, right? Frequency, actually we don't need frequency. And so we're going to say, what do we have here is frequency, tick, time tick, and key. Oh, where's the time tick? Self.tick. Okay, and then self.tick plus equal 1. Then self.map key 0, 1, 2, no 1 equals self.tick. Because it's most recently used, self.map key 0 equal to what? 0 equal to plus equal to the frequency plus equal 1. And shouldn't we do self? No, we don't do. If we don't do it here, we have to do it later. Or do it in put. Like every time we put, we have to reorder the whole thing. We need to make sure. Because if we say .pop, wait, hold a second. Actually, I'm not quite sure. Let's redo this. A is this. Heap is this. Can we just do heap q.heap pop? I don't think so. No, yeah, we have to. When you modify it, you have to redo it. I would rather say we'll do it in the. Yeah, we'll modify it. And then 0. No, frequency. No, that's. No. No. This is. Holy crap. Key value, frequency, time tick, value, and key. My God. I have to get a key and value in here. Key and value. So tick does this. 0, 1, that equal this. 0 plus equal 1. And then we'll return key 1, 0, 1, 2, 3. Return 3. Okay, if it's equal, then we need to pop. Right? So let's make sure that after put, we'll always do it. So let's heap q.heapify self.heap. Then we say if it's equal, then we need to pop. So we're going to pop frequency, time tick, key. We don't care value equals heap q.heap pop self.heap. Maybe it will time out. Who knows? All right. Anyway, we pop it out because this one needs to be removed. Then we say del self.map key. Okay, so remove it. Then we can add. Oh, it depends if it's a new key, if it's an old key. Can we add an old key? Can we add the same key again? Update the value of key if present. So, oh yeah. So this is only if key in self.map, right? And no, it's key not in self.map and is the same. Then we need to pop this, right? Otherwise, we can say if key map, right? If then we just say self.map key. Oh yeah, we have to say if key in self.map. Then we do self. Oh, we need to do it twice. Jeez. Then self.map key 0, 1, 2, 0, 1, 2, 3 or equals to value, right? And self.map key 0 or plus equal 1. Oh, tick. Self.map key 1 or equal to self.tick. Right, that's it. And then you need to reorder it. Right? You need to reorder. Let's see how the reorder works. So we know we have to reorder this one for sure. We need to reorder. Then we need to pop key not in this map, right? Then if this, then we need to pop it, delete it, then we add it when we add a new one, right? Now we add a new one. Otherwise, key is in it, we update it, then we need a heap file. Right, then we need to, because we changed it, then we need to heap file it. Else, if key is not in self map, then we need to add one. Now when we add one, we just say self.map key shall equal to frequency 1 time self.tick. Key is key, value is value. And then heap q dot heap push self dot heap push self dot map key. Okay, that's it. So heap push does everything. Heap file does it here. So we basically, if it's not in, then we have to do a push again. So it's kind of twice. Ooh. But we need to pop first. Right, this is unnecessary. This is just something we have to do. Yeah, you know what? This is actually good because we only heap file if we need to pop. If we don't need to pop, we go directly here. If it's inside, we just do this and then we heap file here. If it's in, then we don't do it. We do it. We do one time heap file. If it's not in self map and it's smaller, then we don't do this. We don't do this. We do this. Then we push it in, and then it will heap file everything. So this might be. Let's see if it works. Not sure. Yeah, it worked for this one. Maybe time. Oh, 0. Wow, I think we're gonna repeat the previous one again. Holy cow. 0. 0, 0, 0, 0. So that's a special case. Did not think about this. So the size could be 0. Yeah, then we should not. We cannot pop anything and we cannot push anything. Right? Then if we cannot do anything, basically we just say if self.cap is equal to 0, or if self.cap is equal to 0, return. Right. That's basically this. Think then we are going to timeout. That will be exactly the same as last year when we do it. Interesting. So there are better ways to do it. I remember there's a better way. I forgot. I don't remember. I forgot. Yep. Because it's not 01. I think this is the old method. Yep. I think this is how this is how I tried to do it the last time. Funny thing, I don't remember the actual solution at all. Holy crap. Alright, think. Gotta be a way, right? Gotta be a way. Least frequently used. If I add something, okay, and then I check this thing, I can increment its usage. I want the least frequently used, so the usage is the lowest usage. Now we can handle frequency, and we can handle the last recently used, but the frequency. How do we do frequency? Right, we put the value, we update the value, then you use it again. Then what? If we move it away, hold on, let me think. I put 1 here. Okay. And then put 2, 2. This is the most recent. Okay. Then we take 1, that's fine. Then 3, 3. And then we need to pop. Then let's say we'll pop this. Then 3, 3. Oh wait, hold on. 2 gets popped. Again. We go 1, 1. 2, 2. Alright, put 1, 1, put 2, 2. And then we call 1. Get 1, so we put it here. And then we want to do 3, so this gets popped. And 3 comes here. Get 3. Put 3, 3. Get 2. Nothing. Get 3. So it's remain here. Oh, that's not right. You can't put it here because this has more frequency. Yeah, that's the thing. How do you know? How do you know? Like, you gotta put it somewhere. Frequency. If it's a lower frequency in this, but they could also be yeah, one have more frequency. And then when new thing comes in, it always has the lowest frequency. But if other things have lowest frequency, you're saying we search? Then you have to search every single time. Come on, a new thing comes in, we always have a low frequency, right? So we shall only go up if the usage, because this won't be the most recent used. So we can, go there if that's the key and the value is the address. Okay, value is the address. I'm thinking about doubly linked list. If I want to add, and the key is there, we go there and then we check. Then we know its value. Then we have its frequency. Then we have to move the frequency upstream. Right? We need to move up. Check, move up. Check, move up. And every time we update something, we might have to keep moving up until frequency is the same. Then we need to check the clock. And every time we have to move. We have to move. How do we get to 01? Yeah, because your frequency change. maybe you put this, so we guarantee it's correct. I don't think so. And just balance out the two. I think it's still in timeout. Man, I just don't remember. They don't even have the hint. Four, 3. Yeah, only 23. I know RU cache. Linked list. Yeah, I know it's a doubly linked list, but how do we arrange this thing? It should be a dictionary where we hold the okay, how about frequency? Frequency is easy. Every time a new thing comes, we just cut it and put it in the front, right? And then we always pop at the back. That's it. That's it. Because that's the, every time we use this, the most frequently used, so we put in the front, right? So whatever is left at the rightmost is always going to be the least frequently used. So every time we use it, we push in the front. Every time we use it, we push it in the front. Yeah, so that's the least frequently used. Least recent used. It is a doubly linked list. It will be 01. But now we have a frequency. How we handle frequency? Something starts to come back, so I just need to marinate a little bit. I think the mechanism, because it has LRU in it as well, so we can do the same thing every time. Yeah, we do this and we push to the back. Push to the back. Hold on. Maybe that's the case. What if we have multiple? Right? Because LRU cache is we don't care about frequency. So everything is one linked list. Now we have frequency, right? So we need, for each frequency, we need a linked list. Every single frequency, we need a linked list. So when it's one frequency, we push in a one linked list, right? If this one does again, we check, we cut it out, we push into the new one, and then we, every time we push it in, it's gonna go to the back. And then if we do it again, we take it out, we push to the higher frequency, just like that. And every time we use, we push in front. And when we pop, we always pop the smallest, right? We pop the smallest. And if the smallest doesn't have, we go to the two frequencies too. If it doesn't have this frequency, like one of them will have the smallest frequency. Ah, now I get it. Now I get it. Holy crap. Okay, I know how to do this. Implementation. We need to do a doubly linked list. But do we? Yeah, we do. Double linked list. We need to cut it out from the linked list. Okay, so everything will start with a dummy, which makes things a lot easier. And then we will basically two functions. Cut, right? Class node. DL node. Okay, we know that's a double linked list. Initiate self. We know do we need a key? Key will go to oof. So we have a hash map, which is key and value, but we also need to know key, value, frequency, and the node address. Then we go to the frequency, and then we go to the node address, cut it out, and then we make modifications. So, and for this, for the DL node, I mean, we can put value in the DL node. We can put a value there. Okay, we can put a value there. And what else we need to put it there? Frequency will be where it lands, so it doesn't really matter. Frequency should be in there. That's it. We only need a value. That's all we need, right? And I'm not gonna do anything else because it's fine. I can say self.val equals value, self.pre none, self.next prev next, both are none. So this is your doubly linked node. Okay, so capacity is capacity. This is still needed. Map is map. We just need frequency. We don't need timestamp. We actually can do value. Okay, we have your value. No, we don't need value. We need the address and your frequency. That's what we need. And we're not gonna do heap. We're gonna do self dot frequency is gonna be a dictionary, not dictionary. This gonna be a list of doubly linked list. Doubly linked list. We don't need to do this. We don't need to do tick. Okay. All right. Let's do this. Oh, this will be fun. This will be so fun when I have say def add. Okay. We need to know add. Add. We have a linked list, a doubly linked list. We need to know your head and your tail, right? That's the two things we need to know, head and tail. And the frequency, we do this. We'll start from 1. And we need head and tail. We can call it -1, right? Head and tail. So, oh, great. Head and tail, right? Head and tail. Because if I had a head and tail, that will make things a lot easier. I mean, to remove, we don't really need head and tail. To add, I need tail. I don't need head. I do not need head. I do not need head. Then how do you know something is empty? Holy crap, I do not. So you do need head and tail. So this is going to be head and tail. Both are dummy nodes, okay? Address of head, okay? Address of head. Address of tail. So in that case, when you add, we always add to the tail. So we have the tail. I think it's an integer, but I'm not gonna do anything. Which actually not. It's gonna be a DL node, right? So that's the tail, right? We need a tail and the current node because we need to add it to it. So the node is gonna be a DL node. So we add this DL node into the tail, okay? We don't return anything. Now what do? We always add inside. We don't really add to the end because that will make the add complicated. So what we do is, hold on, we're gonna say tail dot pre. Yeah, I like to say pre instead of pre. So tail dot pre. Right. So tail, we have a tail dot pre. So tail dot pre dot next equals node. Okay. Tail dot pre dot next and node dot pre equals tail dot pre. I haven't changed that yet. Okay. Tail dot pre dot next, node dot pre equals tail dot pre, and node.next equals tail, and tail.pre equals node. That's add. All right, when I say delete, these are internal methods. We need a head and, do we need head and tail? Well, if it's delete, don't you just need to know the node itself because it's doubly linked, right? I just need to know the node. For this, I just need to know the node to be deleted, right? So to delete the node, we will say node dot pre dot next equals node dot next, right? Node dot pre dot next equals node dot next. Node dot next dot pre equals node dot pre, right? And then node equals none. Take it out. That's delete the node. That's it. Okay, so let's do get. Okay, let's do get. How do we do get? This is fine. If it's not in this, that's perfect fine. Now, to get a node, which is inside. So the first thing we need to do is find its address, okay? And we need to update its frequency. So we need its previous frequency, right? So we're gonna do address and frequency. Let's get the address first. Okay, so not the address, so let's get the node. Right, so we say node equals self dot, yeah, this is gonna be just node. This is gonna be head and tail. There's no address here actually. Okay, so self dot map key and 0. This is the node, right? And then we need to increase the node's frequency. So self dot map key 1 plus equal 1. Its frequency improves. And then we need to, oh no, hold on. We need to first we need to cut it out. Okay? We need to cut it out. How do we cut it out? We say self dot delete node.
You want the description or just the picture?
Both, please. Okay. I can do airdrop.
A cupcake or no?
Cupcake, no.
Are you MacBook Pro?
Yes, a MacBook Pro.
Does it say Nate?
Try it. There we go.
Hey, awkward. Random person.
Wait, I never did this with you on this one. Interesting. Okay, that's it.
Oh wait, it should have been the other laptop.
No, it's okay. I don't use the other laptop anymore. Perfect. Thank you very much. Oh, it's time. All right, I'll be back. Let's get them fed first. No. Tiny tiger. This is one of the more fun problems I solved the last time, February 2022, and I forgot how to solve it again.
Stop.
Alright.
Not on purpose.
No. And then I think I remember how to solve it. It's gonna be a lot of effort to implement the solution.
So you got it?
I got it, thank you. Look absolutely lovely.
I can put the picture in that park highly.
Yeah.
Cause these days I don't have anything, so I repeat.
And this one will be cool. But the one with the shiny beads.
Yeah.
Why fish and tuna? It's all fish. They all love fish.
Fancy food?
Tiny tiger. She was like, I'm not a tiger. I'm a
Jaguar.
jaguar. still left over for you. Course. You're welcome. Got it. Got it. Got it. All right. Where are we? We deleted a node, right? And we don't really need to know where it is because it has the pre and post. So we just need to delete it. And then we increment its frequency. And then we can say, we need to say, what? Say if frequency, if len self dot frequency, well, it's already length is 1, so common frequency is 1. I mean, what we can do is just do this as empty, and then we just need to do frequency minus 1. We can do that, which is fine. So we say len of this, right? If this is smaller than self.map key 1, smaller than the frequency, then we need to add 1. Then let's say self.frequency.append. Append what? It's gonna be a head and tail, right? So I'm gonna say head shall equal to a DL node. Well, that just equals minus 1. What's the default value? Yeah, minus 1 is fine. So head equals DL node, and tail equals DL node, and head dot next equals tail dot pre equals head. Then we append head and tail. Sometimes I wonder if I need a head. I don't really think I need a head though. I probably just need a tail. I probably just need a tail. Like, why do you need a head? We can get the head from the tail. Although we do need a head when we create it. But here I just need the tail. Right? We're gonna put the tail in if it does not exist. If it exists, then we don't. Right? And then we're gonna do, so we add it, and then we just say self.frequency. The current frequency should be self.map key 1 minus 1 when we access it. Okay? So this is the tail that it should belong to. Right? Then what we need, we take it out of the previous frequency, and I'm going to put in the new. So self.add node to the new tail. Add it to the tail. And every time new, we just keep adding to the tail, or we take it out. And we will return.
This thing is so clean. And the water goes out faster.
Oh, really? That, I don't think I did anything special.
Yes?
Oh.
Maybe that glue was blocking.
You know what? I think you're right. I wish you have an awesome, gorgeous, wonderful, strong sleep. Wake up tomorrow feeling energetic and hugging. Jim, how it doesn't work anymore. Oh yeah. Nah. I'll enjoy it a little bit. No, hold it. No, I don't even try. Lost cause on both ends. Jimbo. Jimbo. I see his tail. Come on, Jimbo. Come on. Come on. Jimbo. Jimbo. Yeah, all right, back to it. Yeah, we just need to add it to the end, and that's it. And then put. Okay, let's handle this put. How do we put? Well, first of all, we check if the key is in there. Okay, if the key is in there, so if key is in self.map, okay, if key is in the map, then we basically need to update a value, and we basically do the same thing here. We need to do, oh, we can probably call a function on this. Node equals self.map key 0 increment frequency. Right? Basically is just delete itself and add it to the next one. Right? Well, increments frequency would delete it. Oh, we need a new frequency. Right, so we get a new frequency, and if this is smaller or equal to new frequency, then we need to add one. Then this is new frequency minus 1. No, self dot freaks new frequency minus 1. Right, so here get the node, we call self dot increment frequency node. Oh, we need to do self dot map key 1 is frequency plus equal 1. So that's the new frequency. Self dot map key 1. Ah, node and frequency. I don't even need to do this. Oh, I do, because I need to return node.val. And I need to do this. Damn. Alright, that's fine. That's increment frequency, right? So here is the same. We need this, and then we'll do this, right? Because I put it, it's frequency plus equal 1, increment frequency, and then we need to update the value. So node.val equals value. Done. That's it. That's all we need to do if key is in map. Now else, if key is not in map, then we have two scenarios. One is we need to pop. And to determine whether we need to pop, we need to know the capacity, right? I mean, oh, the cap can just decrease every time we add a new one. We put a new one, we just decrement it, and eventually it will just keep at 2, right? So we can say elif if else, right? And then we say if not self.capacity. We have no more capacity, right? We have no more capacity, we just need to pop some, and then we add some. Right? If it's no more capacity, then we need to remove, so we need to go through from the front to the end and to see if, oh, how do you know there's Yep. We do need to know, which means we need head. Alright, we need the head and tail. That's how I tell if the two are the same. Okay, unfortunately. Head, tail. And then, no, I just need tail here, so is this 1. Everything else is the same. Everything else is the same. So if not self.cap, then we need to go one by one to see the first one that's not. Then we need to remove that. Okay, then we say for head, tail in self.freaks. Okay, if head done next is not equal to tail, we can say tail dot, let's say tail dot pre is not equal to head, then oh, then we how to get it back into the map. Lord, we need the key value here. So we have key and value, so we can delete from this. Damn. Okay, nothing need to change. It's fine. Okay, we want to delete. If this is not equal to, then we're gonna break it. Right? Now that we can delete this. Then we say key equals, I have a key already. Then we can just We want to delete this, right? We want to delete this. Now we just say del self.map key tail.pre.key. That's the key. Or delete that, and then self.delete tail.pre. We delete this. Then we're done. Break. Right, we just keep going to see which one we need to delete. And then once we're done, self.cap plus equal 1. Capacity comes back. Right, and now we break. We've done it. If not capacity, we do all of those. Then we will get the capacity back. Then we add a new key value. Right, so we can say node is equal to dl node key equals key, value equals val is value equals value Okay, so we get a node, and then its frequency is 1, right? So self.map key shall equal to node and frequency. So node and 1. Then what? Then we need to self.add. Right, self.add node and frequency, node and tail. Self.add node. What's the node? Node is this node. What's the tail? Tail is going to be, no, we do self.increment frequency. Increment frequency. Add to frequency, not increment frequency. Add to frequency. Okay. So when add to frequency, we need a node, and new frequency is 1. Right? And after that, after we finish adding, self the capacity minus equal 1. So we plus 1 or minus 1, we cancel it out. Otherwise, we don't do anything. Okay, let's try this one. Uh-oh. I think I none type. Is it the first or is it the second? Oh. Capacity. Damn. That's not how we're supposed to do, man. If capacity is 0, and when we get, that would be not in map. That would be minus 1, that's fine. What if we want to put? If we want to put, and capacity is 0, we say if key is in there. Well, if capacity is 0, key might be in there, but now key is not in there. And I would say if not capacity, then we try to add. But in this case, we don't even have capacity in the first place. Lord, no, I don't need. I cannot do this. I need to do count. I need to do count. So basically, if capacity is 0, which means input capacity is 0, then always minus 1. right? And then everything else is fine. And here should be if self.cap is 0, is a return. Otherwise, if key is in matter, then this is not right. If self.count equal to self.capacity, then self.count minus equal 1, and then this is self.count plus equal 1. So we add a count. Okay, let's try this. Yeah, let's not do this. So this is a doubly linked list hash map and a list to use a list to represent a doubly linked list for each number of frequency. Yeah, that's basically it is. And then with this, I think we can handle the issue of capacity is 0. Ooh, pending. Oh, we still have this issue. That could be the first one, not the second one. Hold on. All right, there's something wrong. Okay. What happened? Let's see again. All right. Now the idea is we'll always have head and tail. Once we're in this, head and tail will always be in there, right? And the head and tail, they'll always connect to each other. And when we add, we always add to the tail. So we say tail.pre.next and node.next is tail. Tail.pre equals node. That's correct. Delete. Delete. We probably shouldn't do this. Just a guess. And no, it has nothing to do with that. But we definitely should not set it to none, because after delete, I think I need to use it anyway. I see that. Yeah, because I delete it first, and I'll add it later. So if we do none, then we basically just remove it completely. I need to do delete node.pre.next equals node.next. And node.next.pre equals node.pre. Node.pre equals none. Node.next equals none. How about we add this one? This is definitely necessary. Okay, but this one will remain in there. Okay, so we add to frequency. We get a new frequency, right? So we'll first delete this node. Okay, because it's the old frequency. So we delete it. That's deleted. And then we will check if the length frequency, if it's smaller than the new frequency, then we will create new head and new tail. Head on next, tail.pre, and then we'll append the head and tail into it. Wait, why do you need head and tail? Well, because I need to check if it's And then we will say we'll add new frequency -1. Right? That's the frequency we have. And then we take 1, which is tail, then we add to it. When we add to it, tail.pre should be the head.next equals node. And node.pre point to head.pre. Okay? And node.next print the tail. Tail.pre point to the node. That's how we add it. I don't see any issue here. So we get a node given a current key, right? Oh, of course, if a key is not in map, we to -1. Key is in map, we get a node, we update its frequency, then we need to add it to the new frequency. So we get a node and we get self.map key 1, that's the new frequency, right? Once we're done, node will be added to the new frequency, and then we will do return node value. And when we put if a key is in map, I'll get its node. That's exactly the same, right? These three is exactly the same. And then we will do the node. Huh. And node.value equals value, we update its value, which is totally fine. Else, if the count is equal to self.capacity, if it's not, we just create a new node, right? Map key is node, frequency is 1, we added the frequency, we add a node to the frequency, and then we plus 1. Seems totally fine. Because every time when we do it, we increase the frequency, we always push to the end. We always push to the end. Wait, are you supposed to push to the end or push to the front? Okay, that's one problem. You're supposed to, hold on. Frequency increase every time you call it, right? Frequency increase, so you delete from the current, you put a new one. Yeah, that's the most recent. You push at the back, and when you delete, you're not supposed to delete tail.pre. You're supposed to delete head.next. But we will have the same issue. But at least this is an issue. When you delete, we delete the wrong thing. We delete the wrong thing, man. Should delete head.next instead of, because the least frequently used is not equal to tail. Then delete self.map head.next.key, and then this will delete head.next. Let's see, we delete head.next, what's gonna happen? We delete head.next, so we delete this node, head.next. This one dot previous dot next, this one dot next, this one dot pre, and this one dot next dot pre will be this one dot pre, and this one just completely deleted, right? We'll delete this, and then we add. So we add this. I think it's still gonna be wrong, but let's do this first, and then see. All right, we gotta see. This is weird. Like, it feels all right to me. What did we get wrong? Let's print key value. Let's see which one got wrong. Oh, we get 1 1. Okay, 1 1 is put, so we put 1 1. Holy crap, we put 1 1. We put 1 we did not even do, because if we do get, we shall print out the key. So we didn't even have the key. So when we put 1 something's wrong already. We put 1 self the capacity is not. So capacity should be 2, right? And key in map, no, so key is not a map. So it's going to be this. Self.count equals to self.count. That's not true. So none will be this. And then we'll add to frequency. When we add to frequency, we'll delete the node first. Holy crap. That's where the problem is. That's where the problem is. You cannot delete node first. This node has not been added to anything yet. Easy fix. If new frequency is larger than 1. Okay. Let's remove all the print. Small issue. Then let's put this one back. Oh, this one should be right because we have a guard. We put a guard there, which literally will ensure everything will be right. Oh, we can try this. Jesus. My God. Okay. I think that's probably right. 1000 milliseconds. Okay, that should be a technical issue. I can't even test it on my own system because I am just too lazy to do this on my own system. Hold on, we need to push everything here. Put this one here. What happened this one? 2. Put get. So we put 3, put 2, put 2, put 4. 3 should be coming out. Get 2. 2 should be 2. I got 1. I update the value. Note the value. I don't know why I say val. I think it was an oversight. But how does the other one work? Dude, how does the other ones work? Man, this is that's weird, right? How does the other one work? Oh, we never put the same value again. I guess that's when the other one works. Yep. Let's go. Come on. Judging. Got it. Yeah. Right? You remember. It's the key, right? It's the key. Is, yeah, that's the... All right. So... All right. Have we done this before? We did this in February. All right, February 27th, 2022, February 27th. I knew LR cache, least recent use, LRC, least recently used, LRU cache, right? LRU cache is doubly linked list. I initially forgot how to incorporate least frequency used. I knew the heap is not going to was not going to cut it due to time complexity. The trick is to use a doubly linked list for each frequency as implemented below. Yeah. I think it's amortized 01. Right, amortized 01. Because I think these are all 01. Right, this is 01. Get is 01. This is also 01. And we can even write a function called getNode. Right, so we can simplify this one as well. But I guess it's fine. Doesn't really matter. And yeah. And this part is 01 as well. The only part that is larger than 01, and this is 01, is this. Is when the count is the same, so we need to pop out. But if we add a new one, then this will only run once, right? It's only if we keep get put, and then push the frequency really high. Then if we push the frequency really high, then it will be a lot of this, so it will be all one. And then we'll only have once we'll do this. So amortized 01 for both get and put. Okay, so now we can check the previous solutions. Doubly linked list. Oh, I put add and remove here. Oh, okay. Do you like this one better, huh? That's okay. I don't understand what I wrote. Wait, how did I... Minimum frequency. Oh, I have a minimum frequency, so I don't have to search. That's true. That's true. Yep. Update. We can keep track of mean frequency instead of searching for it. Wow, in that case. And in that case, self.freaks only need to keep tail. I don't even need a head. So in that case, we only need a tail. Okay. Everything else is the same. I don't really think we need to change much. Only thing changes, I need a self dot minimum frequency. Let's start with 0. Right, if, yeah. But what if in this situation, it popped away to add the next one? Then how do we know? How do we know it's empty then? Right? Oh, we add to a new frequency. Add to a new frequency. A frequency larger than 1, then we need to delete node. But I need to know if this is the last one in this frequency. Okay, so I think this is where we know. This is where we know. Because if there are still frequency left that I don't change, if this is the last frequency, if the frequency is the same, so the new frequency, add to frequency, old frequency, so we need to see, this is a new frequency, so we have an old frequency, right? So when we delete, should we delete from the old frequency? And then how do we know that? That's the issue with. No, we can know. It's just a little bit convoluted. A little bit. Okay, a little bit. So basically, we're gonna do here, right? But before we delete, we need to know if new frequency, if self.min frequency is equal to new frequency minus 1. Okay, if they're the same, and now I'm going to delete one, then I need to know if this is the last one. So we say if this and node.pre, which is there's a previous one. Oh, you do not know. I do. .pre is none. Right? Node.pre is head. Head.pre is none. So if that means current node is the last one. Because every time I and node.next is none. Right? Then self.min frequency shall equal to new frequency. So this is node is the last one in the min frequency. And if we remove it, this has to update. Then that's fine, right? We update the main frequency. Every time we do add to frequency, so this one we update the minimum frequency. And if it's the same, but any one of this doesn't match, that means we have at least another node. Then we don't have to change it. But if we do, we have to change the new frequency. And then this should be fine, right? That's get. We do put. Basically, we do the same thing here. And here, if count, we just want to find the minimum frequency, right? So what do? Well, we already find the head and tail. Okay, say head, no, tail. Lord. You need a head. You need a head and tail. You need head and tail because we insert through tail. You delete through head. Lord. Yeah, thank God I didn't think I changed anything else. And this is all fine. So yeah, we have to have head and tail. Head and tail equals self.freaks self.mean frequency. Okay? And then we need to delete this, and then delete this, update count. Okay, head tail, or delete head.next count, and then if head.next is equal to tail, that means we delete everything in this frequency, self.mean frequency, because that's the minimum. So shall be plus equal 1. Yeah, this one count is equal to this. But actually, if key is not in map, it's actually fine. We don't even have to deal with this. We delete it, and then self.mean frequency always equal to 1, because we just add a new one. Okay, let's see if this one works. Again. So we put first, right? Capacity, no. So we say count, no. We do this, and we add the frequency node 1. What? Don't do this. We do this, head and tail. Done. Count plus 1. Main frequency is 1, okay? Then we add another one. New one. Yeah, we can try. List index out of range. Very interesting. Oh, -1. Interesting. Head and tail. Delete. Print key value self.main frequency self.freaks. Need to analyze this. Okay, 1 and 0, 2 to 1. So we're adding 3, 3, 1. Okay, we're adding 3, 3. Main frequency is 1. That is correct. That is correct. Because after this, so we add 3, 3, 1. Capacity is 2, right? So count equal to capacity. So we do frequency 0. I have a head and tail, right? Head and tail. Frequency 0, we have head and tail. And then we try to delete head down next. So we do del head down next. I think we did it. Because it's we call this function. Wait. It doesn't make any sense. I think it's the get. Yeah, we do this, then we get 2. Get 2. Oh, we forgot to delete. Head, tails. Delete head down next. We forgot to delete self.map. Head down next dot key. Looks promising. Let's move the print statement and put back our gigantic test cases. We're lacking the one that got us wrong last time. But that's because of the value. We changed it. Okay, let's try this one. Good. This is true or 1. Now it's true or 1 for both get and put. This is 909. This is 909. 989. 50. Okay, now we're happy. I use 2 hash maps, which is fine. Alright, that'll be it. That'll be it. Yeah, I don't have the kana to deal with this error. I'll see you guys tomorrow. Adios.